Hello, my name is Mohamad Iswandi. I will be your presenter for this lab session. Here, as we can see, there is design for a bread dish, and there is a little bit of change with the measurement. There is thickness between the G area, which is, as we can see from this criteria, the diameter also the same, but the thickness between this area will be 15, and this area thickness within this area, I change it to 10 millimeter. That's all. Now I will show you guys a simulation for von Mises stress.
This is data finding for our group. First, define material properties for rotor disc brake. For number 1, properties for yang modulus. As you can see, we got 2a plus 011, which is unit in Newton meter square. Second, for Persian ratio, we get 0.266. The third one is density. The value is 7,860 kilogram in meter cubic. And then thermal expansions, which is as you can see 1.17 in K degree. Then use strengths in Newton meter square. The material that we are using for this rotor disc brake is steel. Next, for table result for von Mises stress, force that applied at the brake pad is 2680 kN. For maximum von Mises stress is 2.94 in Newton meter square. For maximum von Mises stress is 7.84 Newton meter square. International displacement is 274. This is for factor of safety, which is minimum von Mises stress divided by maximum von Mises stress, which is 7.84 multiplied by 10 power of 8 divided by 2.94 multiply 10 power of 11, then we get 26.6667 multiplied by 10 power of 18 Newton meter square.
Based on the data provided, the safety factor of the bread disc is 26.6667 Newton meter square. This means that the bread disc can withstand a load of 26.6667 Newton meter square times the yield strength of the bread disc material before it's deformed. The fact that the safety factor is greater than 1, which is a good thing. It means that the bread disc is designed to withstand the significant amount of stress before it's deformed. However, it is important to note that the safety factor is not a guarantee that the bread disc will never deform. If the bread disc is subjected to load that is greater than the safety factor, it will deform. There is a number of factors that can affect the safety factor of a bread disc, including the following: the material of the bread disc, the design of the bread disc, the manufacturing process, the operating condition of the bread disc. It is important to select the bread disc that has a safety factor that is appropriate for the intent application. For example, a bread disc that is used in high performance vehicle will need to have a higher safety factor than a bread disc that used in a passenger car. Overall, the safety factor of the bread disc is good measure of its ability to withstand stress before it's deforming. However, it is important to note that the safety factor is not guarantee that the bread disc will never deform. In case the bread disc in our study shown the safety factor is 26.667 Newton meter square. In case of the bread disc in our study, the safety factor is 26.6667 Newton square. This means that the bread disc can withstand a load of 26.6667 Newton meter square times the yield strength of the bread disc material before it deforms. This is a good safety factor, but it is important to take steps to reduce the stress on the bread disc, such as reducing the brake pressure and using different type of brake pad. In conclusion, the data indicate that the brake disc is likely to deform experience other problems such as a brake judder and fade. This is because von Mises stress in brake disc is significantly higher than the yield strength of the brake disc material. The safety factor of the brake disc is 26.6667 Newton meter square. This means the brake disc can withstand the load of 26.667 Newton meter square times the yield strength of the brake disc material before it's deformed. This is a good safety factor, but it is important to take steps to reduce the stress on brake disc, such as reducing braking pressure and using different type of brake pad. Here are some specific steps that we can take to reduce the brake risk. Here are specific steps that we can take to reduce the risk of brake disc deformation. Firstly, reduce the braking pressure. This will reduce the von Mises stress in the braking disc. Secondly, use different type of brake pad. Some of brake pad designed to reduce heat generation and brake disc deformation. Lastly, upgrade the brake system. This may include installing larger brake discs, more powerful calipers, or brake cooling system. If we as a consumer are experiencing brake judder or fade, it is important to have a brake system inspected by a qualified mechanic. They will be able to diagnose the problem and recommend a appropriate repair. Thank you.